Hi, and welcome back to another episode. Now that I've got my second MicroVAX 3400 working fine, it's time to do the obvious with them, and that is to cluster them. What I'm going to do is create a real VAX cluster, not one of those pretend local area VAX clusters that relies on Ethernet. This relies on shared storage over the Dssi bus and has quorum disks and all that sort of good stuff. Reading from the manual here, it says Digital Equipment Corporation pioneered a cluster technology in 1983 with the VAXcluster system, which was built using multiple standard VAX computing systems and the VMS operating system. The initial VAXcluster system offered the power and manageability of a centralized system and the flexibility of many physically distributed computing systems. Also in the book it talks about the various types of interconnects. There's one called CI, which is the original cluster interconnect that was for connecting the big boxes together through a star coupler and HSC, hierarchical storage controllers, and then later on for the smaller systems such as these MicroVAXs, they developed clustering over DSSI, which is the Digital Storage Systems Interconnect, and also VAXcluster stuff over Ethernet or FDDI, which is a fibre form of Ethernet. I believe that you can also do some clustering over SCSI, but it's more to do with HSJs and those sorts of controllers. So the DSSI controller is built into the motherboard on these machines, and there's a cable that runs up from the system board through to where the disks are. You can see the DSSI disks in there, and here's a typical Dssi disk. This is what's called an RF31, which I think is about 380 megabytes. So that's the typical drive that you use in these machines. This one's got a bigger one in here, an RF71, which is a bit wider. And the Dssi connection runs across and down into this terminator. Now, in order to do the clustering, you take that terminator off and then you connect it to the other machine with this DSSI cable, which plugs into that connector on both sides. Of course, having all the disks on the same bus means that all the IDs must be unique, so you don't have any clashes. And as you can see here, we've got our ID plugs, so that controls the ID of the disk, and also the motherboard itself. It has an ID, just like a SCSI controller has its own ID. The Dssi, the controller has an ID set on it, and you've got to make sure those are unique as well. So this is a MicroVAX 3400 CPU board, and there's some jumpers up here where you change the ID. Usually it's set to 6 or 7, and the disks 0 through 5. Okay, so you can see that we've now got our DSSI cable connected to both machines, and it's time to power things on. So if we have a look at the disks on the first node, see that we've got node 0, 1 and 2, and the host node is 7. So now if we turn on the other machine, we should be able to see the disks in it as well. Okay, we've got both servers on now. So if we do another show device, let's see what it says. So now you can see disk 3, 4 and 5, which are in the other cabinet. Okay, so we can now see 6 disks, 3 in each cabinet. So let's just bring up one of the systems. Okay, this is a fresh build that I've done. Nothing really installed on it, just the basic operating system. If we have a look at the disks, we can see all 6 drives. Okay, so let's start by creating the cluster. None of the machines are in the cluster at the moment, so we've got to run it the first time to put the first machine into the cluster. I'm not using it anyway, but we'll do that. So we want option 1 to add the first node to the cluster, form a new cluster. Nope, we're going to use Dssi. Will it be a disk server? No need, the disks are shared. Allocation class is 1. You have a quorum disk, yes. $1 DIA5. And basically it runs the autogen now to set all the appropriate parameters. Now that we're in a cluster, the boot will be a bit different. So now it's trying to look for the quorum disk. It's found that, so now it's going to wait to join the cluster. Okay, it's now created the cluster, and it'll continue the boot. So now if we say show cluster, it shows that dig1 is a member of the cluster. It's also showing the disks there which are available. And this command just lets you look at the various machines in the cluster and what they're doing. We've only got one node in the cluster at the moment, so that's all we will see. We get a message there to mount the quorum disk, so we're going to do that. Use the command mount/cluster, which mounts it cluster wide. I'll call it quorum. Okay, now that we have our cluster, the next step is to add the second node of the cluster. And the way we add another machine to the cluster is just run the cluster config again. So this time we've got a few more options. So we want to add a node to the cluster. No, we'll call this one dig2. This will be 1.52, so that will make it 1076. Yes. No. So create a new system root, sys1. Okay, and this bit's important. You've got to change expected votes on every cluster member's mod params. So now if you look at you'll see there's a sys0, which is the directory for the dig1 node, and sys1 is the directory for dig2. So let's now swap over to the other machine. So this is the other machine. Do a show dev, we can see all the disks on from this one as well. And this one is Dssi node 6, and it can see 7 as well, which is dig 1. Now when you boot the machine, normally you just put like boot and the disk, but with a cluster you've got to tell it which root to boot out of. Now by default that'll boot out of 0 because you don't specify, and register 5 is the one that holds which root to boot from. So in this case we'll say boot /1 .a0. So this will boot off the same disk, but the first one there specifies the root to boot out of, so it'll boot out of sys1. So it's asked dig1 to join the cluster, and it's been accepted, and it's now part of the cluster. It's just set up DECnet, and now it's got to do an autogen to set the various parameters. Okay, so we'll boot it again. Join the cluster again. And logging in, and we are dig 2. So if I do a show cluster now, we have got 2 nodes in the cluster, dig 1 and dig 2. So you can see the stats there on both cluster members. Okay, so if we go back to dig 1 now, dig 1 can see both nodes of the cluster as well. And we'll just go into sysgen. I'll just set this to 2. The cluster needs a certain number of votes to operate, and that's set to expected votes. So in the case of this cluster where there's 2 nodes, the expected votes is 2. So the cluster expects to see two votes, and if it doesn't see 2 votes, then the cluster will stop and wait until something changes, another machine comes back on or something like that. Now the quorum disk also has a vote. So when both nodes are up and the quorum disk is up, there's 3 votes in the cluster, and expected votes is 2, and everything's fine. If one of the machines falls over, then the votes will reduce to 2, which is 1 for the node and 1 for the quorum disk, so things are okay there as well. If you lose the quorum disk and the node, then this machine will hang and wait for either the quorum disk or another node to come back up. Another thing that has changed is when you do a shutdown, there's an option that says remove. And what that does is it adjusts the number of votes in the cluster so that things don't hang when it goes down. 2-node cluster, all running off the one system disk. Okay, something you may want to do is set up proxy. So that you can go between nodes of the cluster without having to specify credentials. And if you look in the system, there's a netproxy.dat created there now, but it's in sys root. It's got to go into the common. So we rename sys root. So let's put it into the common directory so that both cluster members can get to it. So when you try to access other nodes, like if I say do dig2, it will try to use val, and there's no user assigned with that. So what you need to do is add some proxies. So dig1. So what that means is a user from dig1 will come onto the current node with the same username. And we'll do dig2 as well. So now if we say show me the directory of dig2, it goes in as the system account. And the same with if you change over to dig2, now I can do a dig1. And it goes through system account to system account. Now another thing you should do is define an alias so that you can refer to the cluster with the one name. Instead of saying dig1 or dig2, you can use an alias that will go to whichever one's the least busy. So I'm just looking at the manual here, and they say to do the following. Define node 1 point whatever name. So I'll create an alias called that. And I think you need to do that on the other machine and then restart. So I'll do that and reboot and see what happens. Okay, we've now restarted the cluster. So let's log in. So this is dig1. So we can do stuff like look at files on dig2. We can also look at files on dig, which is the cluster alias. So if we say set host dig, we will get to one of the cluster members. Don't know which one it's going to be yet. So it's dig1. So yeah, we can use that alias to point to the cluster, and then if one of the cluster machines goes down, then it just redirects to the other one. Now a similar thing can be done with lat. So if I start up lat, okay, so I've now got a lat service called dig1. I've also got one called dig, which is the cluster. Now if I move across to the other machine, so now I can see various services. Tesla 2 is a virtual machine I've got running at the moment. So you can see dig1, dig2 and dig. So if I say show service full, it will show me that the lat service called dig points to both nodes, and there's a rating so that whichever one is high will get the preference. So if you look at dig1, it's static, it's marked as 255, so there's no choice there. So if I say set host / lat dig, it'll connect me to dig1. So now it's connecting me to dig2 because the ratings were equal, so it's just picked one. So now dig1's got a higher rating, so if I connect now, it should connect me to dig1, which it does. This can be used for load balancing as well, so that if one machine's particularly busy, the lat service will be offered from the other one. Okay, so we've got an alias for DECnet and an alias for lat now. Another thing that's probably a good idea in a cluster too is to set up shadowing. Just do that on the other side. You can actually do a command that will allow you to do things on both nodes at once. So you can use sysman, and you can say set environment / cluster, and then whatever commands you do will be done on both machines. Then you can say do stuff like show memory, and it will go and run it on each of the machines. Or do show user or something like that. It'll give you it'll run it on each machine in the cluster. So if you want to sort of do certain settings and things like that, you can use that sysman commands to do it. Anyway, we shall now give it another reboot so that the volume shadowing starts working. Just quickly while I'm rebooting, I'll just show you once one of the other machines is down and you do a show cluster, the cluster will adjust its expected votes and still keep working, and just shows that the other one's currently down, but cluster's all okay. And the disks are there and everything seems to work okay. Okay, so we've rebooted now, and we're running on Dssi 0, so it's a shadowed disk, and our cluster should be in good shape, which it is. So now we'll shadow onto DIA 3. And it's off and running. Having a shadow set gives you a bit more redundancy there, just in case one of the drives dies. Unfortunately, you can't shadow the quorum disk, so that can be a bit of an issue in 2-node clusters. When you've got bigger clusters, it's not as much of an issue because you've got more nodes that can maintain quorum. At 2-node clusters, if you lose a node and the quorum disk, then you've got a problem. But once that's shadowed, I should be able to turn off dig1, which holds the DIA 0 system disk, and the system should keep running on dig2 because the system's also on 3 and the quorum's on 5. So I should be able to turn off dig1. Well, I won't be able to turn off dig2 though. I'll lose the quorum disk then. Okay, so as you can see now, the shadow set copy is finished. And we've got 0 and 3 is the system disk. Now what I'm going to do is I'm going to flick the power switch off on dig1. And we'll see what happens. Clustering's detected that that machine is down and go through a state transition, and hopefully in a little while it should wake up. It's lost connection, it's removing it from the VAXcluster, and we've reconfigured the VAXcluster. So now if we have a look, okay, so the first 3 disks, the host's unavailable because they're powered off. Now we've still got our system disk, we've still got our quorum, Show cluster. Dig 2 still a member of the cluster. Dig 1 is down. A bit of time taken to do the cluster state transitions, but cluster is effectively still up. Okay, cluster's looking good again. And we'll have to remount DI0. Normally you'd have that in your startup procedure to mount both volumes at boot time, so you wouldn't have to do that. So I think we'll leave it there. There's a lot more you can do with clusters, of course, but this is just a basic introduction to clustering on smaller machines. Anyway, I hope you found that interesting, and we'll catch up with you next time.